The length of time to run a drip system would depend on the crop. Say you had a plant, say you had one emitter per plant. Say it's a vineyard, and that grape took 16 gallons of water a day. And you had 2-gallon emitters. Well, if it took 16 gallons of water a day and you had a 2-gallon emitter on it, it would have to run 8 hours to provide 16 total gallons of water. And it's a real straightforward process. If you had 2 emitters on the same plant, you'd only have to run 4 hours. So there's an awful lot of option on how long the runtime is, depending on how many emitters you would put on the plant and the flow rate of the emitter. But yeah, what you're doing is you're feeding the plant exactly what it uses. And the efficiencies are excellent. You know, you're looking at 95% efficiency with this. If I put out 2 gallons of water, 1.9 gallons is going to be used by the plant. That's excellent efficiency. Now the compensating style has some kind of a device in there that's going to take and create a pressure differential. And in this case it happens to be a piece of rubber. It's always going to be a diaphragm. And it's a piece of rubber, a very large, it's a good one to show off. And as the pressure increases, what happens is this just pushes against the top and squishes that soft rubber into the groove, the spiral groove that it has to operate in. So it's reducing the cross-sectional area within the groove by squishing the rubber into the groove. And so it's self-regulating. Yeah, self-regulating. So that's what we mean by pressure compensating style. And all the pressure compensating styles are going to have a piece of rubber material in them that has to flex. Now you can see that can be a problem. We have the possibility then of the rubber getting hard over the years, and you lose the resiliency of it, and they don't regulate as accurately as they should. And that is a potential problem. And last but not least, inline style drip. They can be insert, usually again a labyrinth, a tortuous path. The water enters it. It has to go through all of these little channels before it finally drips out the end of it. Please, if you look at this, don't push it all the way together, because we'll never get it apart again. But we have it set up so that you can look at it. And I'm just going to leave it on the table. We have a couple of see-throughs. You can see it implanted in the tube, and there's an exit port. Water comes in, it has to travel all the way around all those little places before it finally can exit. So again, low pressure, tortuous path, no compensator. Yes? Does that come off a lateral then? This would be a lateral. It would, what we call a lateral, would be just a continuous tube down the line, and depending on the crop and the spacing you want, one of these could be every 6 inches, or every foot, or every 2 feet, or every 4 feet, every 6 feet. Like, this is the concept of what they're using out here in the cottonwoods. In fact, they're using this little guy right here, a little inline, and every 6 feet. They have one of these in these big cottonwood farms out here in the Columbia Basin and along the Columbia River. And where every one of these emitters is, they put a tree. And so there's one per tree right down the line. Now, they never use clear plastic, because you would grow algae in here like crazy. It always has to be black. But this is just a demo so that you can get a see-through, so that you can see what it looks like. But that's just a little, again, a little tortuous path internal emitter. And they just string it out on the ground and hook it up with a pressure regulator on the front end. 20 psi feeds the front end of it, and away they go. So I got a few samples of these see-throughs, different manufacturers. And those are the varieties of sprinklers. We've covered the full gambit, everywhere from the half gallon per hour to the, what, 1,300 gallon per minute flow rate. So you can see irrigation sprinklers go from way over here to way over here. And lots and lots and lots of choices for you to make.